So if I gave you $50 and I told you to tell me how much you're going to bet that if I flip a coin, it's going to land on tails, raise your hand and tell me how much you'd be willing to bet. Tayana? $1. Do you think that she made a realistic bet out of $50? No. Now, granted, if it lands on heads, then, oh, she only lost $1. But if it lands on tails, she only gained $1. What's a more realistic bet, Michael?
25.
Why 25? Because it's half, right? A coin, flipping on a coin and landing on tails, you have half of a chance of landing on tails as you do to not. So $25 is a pretty sensible risk that you can take. Let's see if I have a coin. Oh, I happen to have a coin. Let's see if you guys would make money. Want to see? Let's see. Oh, of course it's going to land on the floor. We'll do it again. And it landed on tails. There you go. So you guys would have made $25. Now, had Tayana gone with her bet, you all would have $75. And how much would she have? 51. Tayana, you still want to go with $1? Probably not, right? You want to think, what is a way that you would be able to make a realistic amount of money? So you want to mirror the idea or the concept of how likely those events would be to occur. Let's go on to the next one. I got a die here, right? A six-sided die. It's also known as a fair number cube. And I want to know, how much would you be willing to bet of your $50, roughly? How much would you be willing to bet that it's going to land on either a 5 or a 6? So if it lands on a 5, you win. If it lands on a 6, you win. If it lands on any of the other numbers, you would not win. So think, out of your $50, how much would you be willing to bet, to risk, that it's going to land on one of these two? Think through. Come up with an idea. Write it down on paper. Okay, who wants to tell me about how much would they be willing to bet? What do you think, Zarima? All right, around $10. Anybody have anything different? Okay, Ron? $12. Anybody have anything different? Abdullah? 13. Angel? 1. Again, probably not the best bet, okay? Because you're not going to make much money. Somebody's going to make more money than you. Chris? 15. Okay, anybody anything different? Esther? 5. Okay, so those of you who are around the 15 mark, 15, 12, y'all are on the better bet, because the odds of landing on a 5 or 6 is about $16 worth out of 50. How did I figure that out? How many different things can I land on a number die? How many different numbers are there? 6. Okay, I want the probability of landing on 2 of those numbers. So if I take my $50, I divide it amongst the 6 options that I have. That means each option is worth about $8, $8.33. So I have 2 options I can land on, a 5 or a 6. So I'm going to multiply it by 2. About $16 or $17 is what I would be willing to part with. Okay? Let's think about randomly selecting a male student in the class right now. So take a moment. I'm going to pause the video, allow you to look up. If there's 26 students and there are 11 boys, 11 male students in this classroom, about how much money do you think you should be betting? Angel?
56.
All right, Angel, I'm not calling on you anymore because you're playing around. Vincent, what do you think? You're going to bet all your money? You realize there's less than half the class is boys. Okay, not a realistic bet. Okay, Ron? 35? Probably overachieving. Michael? 16? Underachieving. Zarima? About $22? I'd say around 21 or 22 is perfectly fine. Again, if I said there's 26 students, take that $50. We've got $50. Divide it amongst the 26 students that you could choose from. If I have 11 boys, that means 11 ways that I can win. I'm going to multiply it by 11. It comes out to about $21.15 would be an accurate bet. Okay? Problem 4, spin the spinner and land on an even number. So let me get a spinner out. Here we go. Here's a spinner. How many sections are on here? How many of them are even? 2. So out of $50, how much do you think you'd be willing to bet? Out of $50, how much would you be willing to bet? What do you think, Tayana? Not quite. Vincent? 10? Okay. Not quite. Underachieving. Okay, Ron? Close. A little overachiever. 20. Okay. Again, how many sections? No, total sections? 5 total sections. How much money did we have? We had $50. So what did I say to do? Take your money, divide it by the total number of sections. So divide it by 5. That means each one of these sections is worth $10. So if I land on here, I get $10. If I land on here, I'd get $10. Either one of them is fine. So I have a probability of 20 bucks. Okay? $20. Randomly selecting a pink highlighter from a bag. So if I have all my little highlighters, here's my highlighters. How many colors? 5 colors. How many of them are pink? 1. So now let's think about it. How much would be a good bet out of $50, George? $10. $10 would be a good bet. Okay? All right. Pulling a heart from a deck of cards. So a deck of cards has 52 cards, right? They're all split up amongst certain suits. You can have spades, you could have hearts, you could have diamonds, or you could have clubs. Okay, so how many options are there? 4 options. So what would be a good bet if I just could pick any heart? Any heart, doesn't matter which heart, doesn't say queen, it doesn't say like a 4 of hearts, it just says a heart from the deck of cards. So you've got 4 options. You just want to choose a card that has a heart on it. About how much money do you think would be worth the bet? Who hasn't answered? Somebody who hasn't. Sophia, you want to try? Not quite 20. Use your calculator. Calculate it. Actually calculate what I showed you to do. Take the money, divide it by the number of outcomes that you could have. Okay? Marlene? Not 26. Okay, Ron? About $13. Yep, $12.50 or $13. So anywhere between $12 to $13 would be a good option. Okay? Betting is, again, all it is just based off of probability, and that's what we're going to be talking about for this unit. This is probably one of my favorite units, this unit and the next unit. These are my favorite ones. Love these 2 units because they're very abstract and a lot of hands-on work. Okay? So here, talking about what probability encompasses, we are focusing on experiments. So an experiment, when I flip the coin or when I roll a die, that's an experiment. That's a physical action. It's kind of like when you're in science class. If they're talking about doing an experiment, are you just sitting there and doing nothing? No, you are physically performing something. That's what an experiment is. Okay, it's an activity that you're performing that involves chance. Stop. A trial is the repetition or observation of an experiment. So when I flip a coin, that's one trial. If I flip a coin 5 times, so 1, 2, 3, 4, 5, that's 5 trials. The number of times that you are performing your experiment. So maybe write that down, okay? The number of times you perform your experiment. Because anytime that you're doing an experiment is not a good or valid experiment unless you do it often. If you only perform your experiment one time, it's not a valid result. Okay? How many of you have ever gotten a shot? Like a flu shot, COVID shot, any kind of shot. Would you be willing to get a shot if they only tested it on one person? No. Okay, the reason that we are okay with getting shots is because it's been tested over and over and over again. Okay? So the more trials, the better the results, the more accurate the information. The same thing with probability. The more trials, the more times you perform an experiment, a probability experiment, the more accurate the results will be. And we'll talk about accuracy. How does that make something accurate when it comes to a probability? We'll talk about that in a couple days. Okay, an outcome. An outcome are the different results of an experiment. So for coin, I have heads and I have tails. Those are my outcomes on the experiment. For the spinner, my outcomes are a 1, 2, 3, 4, and 5. On a deck of cards, I have the outcomes of diamonds, hearts, clubs, and spades. I also have individual. I have 6 of diamonds. I have 10 of diamonds. I've got hearts, like 8 of hearts. I've got queen of hearts. You've got all sorts of different individual kind of outcomes on here depending on what specifically you're looking for. Okay, and then the event, it's the set of one or more outcomes that you're trying to achieve. Okay, so when I said, hey, what's the probability of landing on tails? That's the event that I'm trying to achieve. When I say how much would you bet on picking a male student, that's the event that we're trying to achieve. Okay, now we have a probability number line. So let's take a look here at this number line. With the number line, it has a range of values, and each of these values is set equal to what we call a likelihood term. A likelihood term. So here, at the very far end, we call this 0. This value of 0 also means 0.0. You can put 0.0. Or 0%. 0%. All of these represent a way to write probability. 0 as a fraction, 0.0 as a decimal, 0% as a percentage. Each one of these represents the event that we call impossible. If it has a probability of 0, that means it will never happen. Abdullah, close your computer. If it has a probability of 0, it is an impossible event. It will never, ever happen. Today is Thursday. How likely is it that tomorrow is going to be Tuesday? 0%. It's an impossible event. Okay? Then you have smack dab here in the center. This is the value of 1/2, or 0.5, or 50%. This has many different terms that we can call it. We can call it equally likely. We can call it as likely to happen as not to happen. Okay, they all mean the same thing. It means it has exactly half of a chance of occurring, which means this coin here is called an equally likely experiment. Each one of the outcomes on here has half of an outcome, or half of a chance of occurring. Okay, so to land on heads, it's equally likely to land on heads as it is to land on tails. 50%. Then all the way at the very, very end, we've got the value of 1/2. This represents a certain chance. Certain. It means it will definitely be happening tomorrow. Like tomorrow is Friday, right? The odds of tomorrow being Friday is 100%. It is a certain event because today's Thursday. We know that that's going to happen. Then you've got these values in between. These values, even though we have some specific values written down here, this is actually set ranges of values. So from here on, we call this likely. That means that it's any value that is greater than 50%, but less than 100%. Any value greater than 50%, but less than 100% is considered to be a likely event. So if it is 50.7% chance of happening, that's considered likely. If it is 99.82% chance of happening, that is likely. And then we have the other end. What do you think we call this one? Not likely or unlikely. Okay, unlikely. Unlikely means it's very small chance of happening. It could happen, but it's a very, very rare chance. Okay, weather. The probability that it's not going to rain today is like 0.3%. 0.3%. It's not impossible. There might be an area where it does not rain today in this region, but it's very, very unlikely. Okay? So unlikely means that it's going to be greater than 0%, but it's less than 50%. Any values between the 0 and 50 percentile is going to be an unlikely situation. Okay, take a moment to get that copy down, then we'll move on. All right, the way that we write probabilities, when we write a probability, we write it as P and then an event inside. So the probability of and whatever event we're looking for. Okay, so when we're talking about that, let's say, for example, we want the probability of a male student. Then I'm going to write P, and then in parentheses, I'm going to write the male student. Now remember, we just said that there are how many male students in the classroom right now? 11. There are 11 male students that are currently in the class right now. And then we're going to put it out of a total. We always put it over a total. So how many total are in the class? Total of 26 students. Okay? So when we're writing this probability, it's just 11 out of 26. 11 out of 26. That would be the fraction. Who remembers how can you convert this into a decimal? What operation would we be doing in order to change a fraction to a decimal? What am I going to do with the 11 and the 26? Abdullah? Huh? You'll divide them, right? If we take 11 and we divide it by the 26. Go ahead and do that right now in your calculators. 11 divided by 26. Okay, when we do that, we're going to get 0.423, so on and so forth. We're going to estimate it. We're going to round it to approximately 0.42. And then who can remember, how do we convert a decimal into a percentage? What do we do to decimals to change them into percents? Okay, Ron? You multiply it by 100. If we take 0.42 and we multiply it by 100, that's going to give us 42%. So here is my probability as a fraction, as a decimal, and as a percentage. Roughly, what is the likelihood that we would choose a male student? Is it impossible? Is it impossible to choose a male student in here? No. Is it unlikely? Yes, because it's less than 50%, right? This would be considered an unlikely situation. We're unlikely to choose a male student based off of how many males we have in the class and how many total students we have in the class. That could change. Maybe next class period I might have more male students. You never know. Okay, but based off of what you guys have currently in the class, that would be your probability of choosing a male student in the classroom. Okay, let's go on to the next page. Go ahead and flip it on over. So what I want you guys to do is I want you to think, what kind of likelihood? Is it impossible, unlikely, equally likely, likely, or certain that we're going to pick a month that has 28 days in it? So think about it. How many months have 28 days in it? February is one of them. Yeah, sure. That's not it. Are you telling me that there's not a January 28th? Is there a March 28th? Every month. That's a trick. Okay? But every month has 28 days in it. Now, if it says pick a month that only has 28 days in it, that would be February. But pick a month that has 28 days in it, every month has 28 days. So every single month is going to meet the criteria for this event, right? So that would be all months out of all the months. So what kind of probability are we talking about? Impossible, unlikely, equally likely, certain, likely, what is it? Certain. This is a certain probability. This is a certain probability. All right, rolling a number that is greater than or equal to 3 on your number cube. So let me find my die. I don't know where my die just went. Oh, here it is. So here's my number cube. How many numbers are on this number cube? 6, right? There are 6 numbers on the number cube. We've got the values 1, 2, 3, 4, 5, 6. Okay, now, based off of that, how many numbers or what numbers are greater than or equal to 3? Let's start with the 1. Is 1 greater than or equal to 3? What about 2? 3. Yes, 3 is. What about 4? Yep. 5. 6. Yep. So that's the 3, the 4, the 5, and the 6. So how many numbers is that?
4.
4 numbers out of how many numbers down here?
2.
No, how many total numbers down here? 6 total numbers. 4 over 6. That's the same thing if I were to go ahead and simplify it. That is the same thing as 2 over 3. Based off of that probability, is it impossible?
No.
Is it unlikely?
No.
Is it equally likely?
No.
Is that 50%? No. Is it likely?
Yes.
Yes. This is a likely event. This is a likely event. All right, flipping a coin and landing on tails. Flipping the coin and landing on tails. Let's start with the total. What are my possible outcomes that I have? Heads, tails. Now, I want to land on just the tails. I just want to land on tails. So I'm only looking for one outcome out of how many? 2. 1 over 2. Okay, what kind of probability is that? Equally likely. This is equally likely. Okay, spinning a spinner and landing on 15. Here's my spinner. What are my outcomes that I have here? I have 5 outcomes, right? I've got a 1, a 2, a 3, a 4, and a 5. How many 15s do we see? None. There's no 15s. So that means it's 0 out of 5. What's 0 out of 5? Impossible. This is an impossible situation. It won't be able to happen. Okay? Now complements. When we talk about complements to probability, that is the opposite of the event occurring. So if I say, hey, I want the probability of rolling the die and landing on a 1, the complement would be rolling the die and not landing on a 1. Okay, so we'd call it the not probability. The not probability is the idea of a complement. You want the opposite of that event occurring. So if we have a bag of marbles that contains 6 red, 6 blue, 3 green, and 1 yellow, the probability that you're going to land on a red or pool of red is 3 out of 8. So we want the probability that you're not going to pull a red. Okay, so probability again is out of one hole. Probability is just out of one hole. So all I'm going to do is just take 1 and subtract 3 over 8. There's another way that I could write one hole though. I could write it as 8 over 8. Is 8 over 8 the same thing as one whole? Yes. 8 divided by 8 is 1. Why did I choose 8 though? Because there's 8 as my total here, right? So I'm going to do 8 over 8 minus 3 over 8. What's 8 over 8 minus 3 over 8? 5/8. So the probability that it's not going to occur is 5 out of 8. Let's take a look at problem number 2. Rolling a 5 or 6 is a probability of 1/3. We want the probability of not rolling a 5 or a 6. Okay, so again, I'm just going to take one whole and subtract the probability that it'll happen. What do you think I'm going to change my denominator to, though? 3's, right? I'm going to do 3 out of 3 minus 1/3. And what does that give me? 2/3. So the probability that I will not land on a 5 or 6 is 2 out of 3. Go ahead and do number 3 on your own. And then we'll stop there. Okay, probability of picking a queen. A queen out of a deck of cards is 1 out of 13. What's the probability that we will not pick a queen, Vincent? 12 out of 13, right? If we do 1 out of 1 minus the 1 out of 13, I'm going to change my 1 over 1 to a 13 over 13. I want to keep the denominators the same. So 13 over 13 minus 1 over 13 is going to give me 12 over 13. Tomorrow for your digital day, you're going to have some IXL to work on. If you do not remember your IXL login, it will be posted into Google Classroom. You need to get to what SMART score? 70 or higher. What's the cap off? 80. 80 is the highest that I accept for your SMART score. So you need to go up to at least a 70. If you go to an 80, that's the extra credit. Make sure that you log in and get that done tomorrow.